Okay, I'd like to show you now how to do synthesis problems. So this would be a typical example of a synthesis problem. You're given a reactant, then you're given a couple of arrows, and then a product. What you want to do is try and find something of this form here, where you start with the reactant, you have an arrow, and above the arrow you'll have some sort of reagent, followed by some sort of intermediate compound, then an arrow, and then another reagent to give the final product. The method I like to use is called the retrosynthetic method. And what that entails is taking the product and figuring out first how the product was made. So we don't start out with the reactant, we start out figuring out, well, where did the product come from? Well, you guys are fairly lucky because on the test, when you get this sort of problem, you'll be able to go back to question 1, which you would have already completed, and you'll be actually able to use the reactions in question 1 to figure out your synthetic process. So your first stop is to look at the product and figure out what the functional group is. This is an ester functional group. There's only one reaction in question 1 here that could have formed an ester, and that's this one here, because this is the only ester that's a product in any of these reactions. So this is how we know this ester was made. We can use this entire reaction, reactants and product, to figure out how our particular ester would have been made. We use this as what I call a template. Right, let's see how that's done. Right, so here is our product, and we need to figure out how that's made. Here is the ester that we know how that's made. Now what we're going to do is I'm going to try and figure out, well, how was this ester made? And then how would this ester be made? Okay, so first of all, let's look at the bits and pieces in the product and where they came from in the reactants. Now if you look closely here, you'll see that this portion of this reactant ends up here in this product, minus the OH. This portion right here ends up in the product. I've put a square around that right here. And you'll notice that we're missing an OH and an H, and that's what's formed the water over here. So that's the first step, is to identify where the reactants are in the product. Now we can use that same method then to look at this and figure out what reactants must have formed this product. Alright, so let's focus on this portion first in our product. That's the one with the C double bond O. If I'm going to cut exactly the same bond, that would be the bond between the C double bond O and the O, and that portion must have come from the carboxylic acid. So in the original reaction, this must have been a C double bond O with an OH, just as this was a C double bond O with an OH here. So that matches. I'll put a square around this part. And I know where to put the circle and the square because I want to put them in exactly the same locations as they were in the compound that we're actually working with. So we're cutting this up in the same way as this was cut up and how this was formed. And this would have been this with the O and an H, just as it was over here. So now I know, and I'll put the H plus here so that that matches what's down here. So now we know exactly what compounds would have been used to form this over here. So far, here's what we have. We know this alkene must form something that's in this reaction right here. We'll take a look at what that something is in a second. Alright, there's our reaction. This is what we know so far. Now we know that if we've got this alkene here, it probably didn't form this, it probably formed this, because that's a square and that's a square. So this is probably more what we're looking at right now. We want to try and get it into this form down here. Alright, so there must be a reaction between this and something to give this alcohol. Then we'll have an arrow and we'll put H plus on the bottom and we'll put our carboxylic acid on top of the arrow, because we know that this alcohol reacts with this and H plus to give our product. Now all we're missing is this business here. We need to figure out what reactant would allow us to get from here to here. So what's going to save us now is, again, that same question that we looked at earlier. Alright, so we look here for a reaction that starts with an alkene and ends with an alcohol. And there it is. That's the one we want. This alkene will give this alcohol, and there's the reagent we would use to make that happen. It's just H3O+. So we're going to use the same thing to get from here to here. So because H3O+ would allow us to get this, H3O+ will also allow us to get this as well. So that's our A product right there, will be the H3O+. So now we can put it all together. We'll have the alkene, H3O+, that gives this alcohol, which reacts with the carboxylic acid and H+, to give us our final ester. Just summarizing the steps, what we did was we started out with the product, and we figured out how we made that product. So we figured out it was this and this that would give this product. And then we went from the start to the middle to figure out how this one was formed. And that's usually the best way to handle synthesis problems in general.